Today we're going to continue graphing trig functions, and specifically we're going to talk about translations and then putting everything together. So we talked about every trig function can be written in the following form, be it sine, cosine, or tangent. We found out that A was amplitude and x is kind of like a vertical stretch or a y multiplier. K affected the period. Basically talked about the time it took for one cycle of the graph to actually happen or complete. X is a horizontal stretch or x multiplier. And then we found out that it's not the period, but it affects the period by, in one case, dividing by 2 pi or 360 if it's sine or cosine, and dividing k into pi for tangent or 180 for tangent, depending on whether you're in degrees or radians. So we're going to talk today about looking what happens to C, and if you remember, C is this term inside. So we take a look at the graph, and we have a normal sine graph as the black graph here. It's starting at 0, which we're used to. It's completing in 2 pi, so the period hasn't changed. All my intervals are the same at pi over 2 and pi and 3 pi over 2 and 2 pi. So the black graph is our standard, and we're saying what happens based on these equations from that black graph. Well, if you look at the blue graph, which is sine of x minus pi over 2, this graph appears to have a cycle that goes from negative pi over 2 to pi over 2. So this period actually is still 2 pi, so nothing's changed here. Still has an amplitude of 1. So the blue graph has not changed in terms of its period or amplitude. So A and K have not been affected. But we notice that instead of starting at 0, it starts its 0 value at pi over 2 and then goes up. All right, so we notice in this case that pi over 2 and this pi over 2 happen to be the same. That's kind of big. Now we look at the next graph, which is sine of x plus pi over 4. Again, I look at this graph and I say, okay, well, where is this guy going to start and stop? Well, if I go here and look at, well, I'm 2 spaces off from 0, and I finish at 2 spaces off from 2 pi. Okay, that's the same exact graph, and the amplitude is the same, it's 1. So the only thing that's changed here is the green graph has moved over half the distance to pi over 2 in the negative sense. So we know that this term then is pi over 4 of the negative type. Therefore, the relationship that exists is if the k or the c value, the c value is positive, we go and move the graph to the right. If the c value is negative and you're saying, well, how is this negative? It looks positive. Well, in the original equation, we notice that theta minus c is the original value of the function. So to make this term look like a subtraction, I have to say x minus a minus pi over 4 in order for it to look like the theta minus c. So if my c is negative, the graph goes back this way. All right, so it's a translation in the horizontal sense. In terms of the effect of D, well, here's my sine graph. Once again, a period of 2 pi, starting at 0, has amplitudes of 1, nothing's changed. That's my starting point, and see what happens when I take and say sine of x plus 3. Well, we notice that the graph starts and stops at the same spot. So the period's the same. Amplitude from the midline goes from 3 to 4, from 3 to negative 4, so amplitude of 1, nothing's changed, but we notice the graph starts 3 higher. So this 3 actually acts as a translation, but it moves all the points in the graph up, while this moves all the points in the graph down, as you can see very clearly in the green graph. So, again, this moves up, this moves down, this is plus 3, this is minus 2. Why is that different from the previous example we have, where they were kind of opposites of that? Because we have a plus sign right here. So what's after a plus sign is actually the vertical translation. And if you'll notice, after plus, we have a 3, moves up 3. This is a minus 2, which could be written as plus negative 2, so that's why it moves down. Putting all that together now, here's our general equation of sine, cosine, and tangent. We've talked about A and K and the period changes. C is what we call a phase shift or a horizontal translation. If C is positive, it moves right. C is negative, it moves left. D is a vertical translation, and it moves the graph up and down from the midline. D positive moves it up, D negative moves it down. So now we're going to graph with some translations. We're going to identify all our terms that are necessary. Notice A is the same, it's 1, hasn't changed. The period, since I haven't got a K value, the period is 2 pi. When we have a 2 pi period, we know that our intervals are pi over 2. We now have a C value, which is inside. Remember, x minus C, so C is a positive. 3 pi over 4 moves it to the right. There's no D value because there's not any addition or subtraction after the parentheses, so that's 0. So let's talk about how to graph this. Now normally sine would start at 0 and then go up. Now what we're going to do is we're going to start at 3 pi over 4. Alright, and my intervals are pi over 2, so rather than think about how far is pi over 2 away, I'm going to change this to 2 pi over 4. So now all I have to do is add intervals of 2 pi over 4, which gives me 5 pi over 4, and then 7 pi over 4, 9 pi over 4, and 11 pi over 4. Whoops. And start my sine from 3 pi over 4. Everything else is the same. I go up 1 and down 1 from 0. Notice from 3 to 11 is 8. 8 pi over 4 is 2 pi, and there's going to be my period. So I move up, down to 0, go down to negative 1, back up to 1, and here's my sine graph with a positive translation of 3 pi over 4, because 0 would be somewhere over here. Continuing, except now notice we are in degrees. This is important because our horizontal axis will now change. A value, nothing in front, so we know that's 1. No K value that we can see, so it's an implied 1, therefore period's 2 pi. Intervals are pi over 2. Got the term inside the parentheses, but it's a plus, so we know that it should be a minus, so that's minus a minus 80 degrees. And negative 80 degrees is our phase shift. D value 0, no addition and subtraction outside. So in this case, we'll take, and since we're in degrees, 2 pi is 360, and pi over 2 is 90. So we're going to start at a negative 80, add 90, which gets me to 10, 100, 190, 280. And you'll notice from negative 80 to 280 is a total of 360. That will be one period of sine. Amplitude still the same as we said before. Start at 0, go up to 1, down to 0, back down to negative 1, finish at 0 again, and there is one period of that sine graph with the translation of negative 80 degrees. Now we're going to start putting everything together, so these guys are all probably going to change. got an amplitude of 4. It's the number in front. My k value is a half. Therefore, my period is 2 pi over 1 half, or 4 pi. I know my period is normally pi over 2. But we're dividing that by a half. My fault. Okay. Which ends up being equal to a total of pi. And then my c value inside is negative pi over 4. And finally a d value of negative 3. So again, I'm going to take and draw a midline, but now I'm moving everything down 3. So I'm going to start at negative 3 and move up 4, which gets me to 1, and down 4, which gets me to negative 7. This is my new midline. Normally, a cosine graph would start up 1 from the midline. Now this starts up 4 from the midline. Alright, so I'll just put that right here. And normally we'd start at 0, but now we're starting at negative pi over 4. And now my intervals are pi away. And again, I'm going to get common denominator, so it's 4 pi over 4. So I add 4 pi over 4 to negative pi over 4, get 3 pi over 4, 7 pi over 4, 11 pi over 4, and 15 pi. I don't need that actually, because I only need one period. If I go from negative pi over 4 to 11 pi over 4, I've got a total of 12 pi over 4, which is 3 pi. I need 4 pi, so I do need more. Sorry. And I have 15 pi over 4. So that's 16 pi over 4 in total length, which is 4 pi. So I'm all good. So again, we start up at 4 away because that's my new amplitude. We go down to the midline from there, down to negative 1, back up to 0, finish at the amplitude again, and then I draw my graph. So this is a stretched vertically and horizontally graph, which has also been translated back and down. So in this graph, we're going to move to a tangent, and we're also going to ask to state the domain and range when we're done with this. Also note we're in degrees, so we'll take that into consideration. Amplitude, since no visible term out in front, is an implied 1. Period, since we're in degrees, is 180 over k, which is 2, or 90 degrees. Intervals is normally pi over 2 or 90 degrees, but I'm dividing by 2, so it's 45 degrees. Translation, since this is a minus, is just 10. And then vertical translation of 1. So again, I'll take and graph the midline, which will be at 1. I'm going to start at 10 degrees and move 45 over, so that's 55, 100. And in that space right there, I should get the whole tangent graph done because there's my 90 degrees. If we remember, tangent usually starts at 0, 0, so now my new starting point is 10 degrees over and 1 up. And in tangent, the first interval always has an asymptote, and then it goes back to 0. And tangent always rises, so this will go up here, and this will go up here as I go from left to right. And that's going to be my tangent graph. Now we have to state the domain and range. Remember, domain talks about the x values that exist on the graph. And when I talk about the graph, I'm talking about the solid black lines. Asymptotes are where there is no x value that's defined. So what I have to do is state, well, the domain is all of the values except for these. In order to better understand that, I'm going to continue to graph. I'll graph more than one period. So if I add another 45, I get 145, add one more, and I get 190, right? And then I'll get another asymptote here. This will continue to rise, and then I'll get my 0 again, and this will rise up to there. And now I can better see where my asymptotes are going to take place. That's at 55 degrees, 145, and then every 90 thereafter, a new period is going to show up, so I'll get another asymptote. So I can't just say it's a 155, 145 and stop, because this goes on forever in all directions. So I basically have to write an equation to say where my asymptotes will exist ad infinitum. So in this case, I'll say the domain is x is not equal to 55, and then every 90 degrees after that, both in the positive and negative direction. So to say that, I go plus or minus 90 n. And that tells me that if I add 90 forever, I'll get an asymptote, and I subtract 90 forever, I'll get a new asymptote. Now the range talks about the defined y's, or all the y's going vertically, and you can see by this portion of the graph here that all the y's that I can think of are going to be in this graph because there's no breaks horizontally. Remember, this is a midline and I'm crossing it. So the domain is all reals. Let's keep going here. Again, we're in degrees, but it's a sine graph now. A is 1 period 360 over k, which in this case is 3, so I've got 120. Those are degrees. Normally my intervals for pi over 2 are 90, but I'm over 3, so that's 30 degrees. 20 degrees is my phase shift. There is no vertical translation, so it's 0. Here's my normal standard midline, and I won't move that because there's no vertical translation, but my 0 becomes a 20, or I'm sorry, yeah, my 0 becomes a 20, and my intervals are 30, so I go 50, 80, 110, 140, and that gets me a total of 120 degrees. One period will exist then. It's a sine graph, amplitude of 1, start at 0, move up to 1, back to 0, down to negative 1, up to 0, and there's my sine graph. Back to radians again, cosine function, amplitude of 1, period of 2 pi over k, which in this case is 2. So I have pi. Interval is normally pi over 2. That's divided by 2. So that's pi over 4. My c value is pi over 4. No d value again. My midline, going to start over at pi over 4 and move in pi over 4 intervals. So this is 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4. That gives me a total of 4 pi over 4 from pi over 4 to 5 pi over 4, which is pi, one period of the graph. Amplitude 1 again, so start at 1, go to negative 1. Cosine starts up at 1, moves down to 0, down to negative 1, up to 1, over 2 intervals, and I connect the dots. Let's do another one. In this case, again, there's no vertical translation, so d is 0. Amplitude's 3, period is 2 pi over pi, which is 2. My normal interval is pi over 2. Divide that by pi, which gives me a half. And then c is a half. So there's my midline. This time I'm going up 3, down 3, starting at a half, moving a half every time, so that gets me to 1, 1 and 1/2, 2, 2 and 1/2, and that's where my period's going to end up. It's a sine graph. Start at 0, move up to the amplitude, back down to 0, go down the amplitude, and then back to 0. And there's my sine graph. Notice now we've got a negative here, and if you remember from before, negatives are not necessarily talked about as an amplitude, but they reflect the graph. So I'll say my amplitude is 2, but it reflects. Alright, I have a period normally of 2 pi, but that's over k, which is pi over 4. So we end up with 8. Intervals normally pi over 2, divided by pi over 4, which ends up being pi's reduced, and I have 2. C value is 6. D value is -4. So now I'm going to have my normal 0 here. I'll start at a C value of 6, move in intervals of 2, so that's 8, 10, 12, 14 gives me a total of 8, so all the cosine graphs going to exist there. I have a midline of -4, so I'll go down to -4 here. And I have a amplitude of 2, so I'll go -2, -6. Draw my midline as such. It's a cosine graph. Normally cosine starts up at the amplitude, but this reflects, so it's going to start down, then move to 0, then go up, back to 0, back down, and that's my reflected cosine graph with an amplitude change and 2 translations. Tangent going through, again, amplitude of 1, period, pi over k, which gives me 1. Pi over 2 is normally my interval, divide that by pi, so we got intervals of a half, C value of a half, D value of 3. Again, move my midline to 3, and I take and start at a half. I have intervals of a half, so that goes to 1, and then 1.5. Tangent normally starts at the midline. First interval has an asymptote, goes back to the midline, and always rises. We're writing an equation now of a cosine function. It's got a period of pi over k, pi over 6. I know the period is normally 2 pi over k, so I'm going to have to find the k value. I note that doing a cross product is probably the best option here. So I've got pi k is equal to 12 pi. Therefore, k is equal to 12. I have an amplitude given to me of 2. Phase shift of negative pi over 10, and a midline at 5. So my D is 5. Therefore, I put all this together and now say y equals 2, that's the A value, cosine of k, which is 12. Theta, I have plus pi over 10, because it's normally minus, and a minus is a plus. And plus 5. Done. Alright, so now we've got to write the equation of a sine function. You'll remember from before, we found changes in a and k. This is going to have a little bit more going on, so let's go ahead and get through it. I should probably find the a value, the period, and then the k value, the c value, and the d value. A is how far I move from the midline to a peak or a valley, and that's going to be 4 in this case. Period, how long it takes a graph to repeat. It's a sine function, so I start at a 0 and end after it goes up, down, and up. So I'm starting here and moving to here. The period is equal to 1, 2, 3, 4. And 2 pi over k equals 4. So k is equal to pi over 2. Divide by 4, multiply by k. And c, I want to know how far the sine graph is moved over. I've got a ton of options here because sine, like I said, usually starts at a 0 and goes up. Well, there's a lot of places it starts at 0 and goes up. I could use any of these as my c value. So I could use, let's just say, -1, or what is that, 3, -5, or -9. Any of those will work. And then my midline is translated up a total of 2. So I'm just going to use a value of, I'll use -1 just since it's here. Alright, so we'll say we've got y equals 4 sine. I'm going to use my translation back of -1, and the pure k value is pi over 2. Theta, minus a minus is a plus, and then plus 2. And that gets it done. And last, let's do a cosine value. Here I didn't put the midline in. You'll have to find that for yourself. Not too hard. You can just count how high it is from the top to the bottom. 1, 2, 3, 4, 5, 6. So if I move up 1, 2, 3, that's dead set middle. Here's my midline. So D in this case equals -4. A value, how far is it from that midline? Looks like 1, 2, 3. Period. Remember, this is a cosine, so I'm looking from peak to peak, and it looks like that far. Period's equal to 2. K value we get from calculating 2 pi over k is equal to the period, which in this case is 2. So therefore, k is equal to pi. And then how far has this moved? Again, cosine usually starts at a peak and then falls. So I've got 3 peaks I could use for my starting point. So I could say at 1, or looks like -1, or 3. Either one. I'll use the 3 this time just for a change of pace. Y equals 3 cosine, k value of pi, theta plus 3 this time. Or I lied. Minus 3 and minus 4. And we're done. Make sure you identify all the bits and pieces before you do any graphing. Get common denominators between your intervals and your phase shifts, and then just realize that all the graphs are going to look the same. It's just all the numbers will change.